All right, so now let's take a look at an example. So how do we apply the formula to this problem? Okay, so I have this problem is summation of k equal 1 to 200, k times k plus 1. So we won't be able to apply the formulas yet because the term doesn't look similar to what we have. So we're gonna have to expand this first. So first of all, we're gonna distribute this until we got the individual term that what we have. So we will have summation of k equal 1 to 200, k squared plus k. Now you have the summation of two different terms. And remember, if you have a summation of two different terms, we can break it down to two different summation. So this it will same as k equal 1 to 200, k squared plus summation of k equal 1 to 200 of k. So now I have the summation of k squared, which is n times n plus 1 times 2n plus 1. So we put the formula in, times 2n plus 1, and then over 6 plus n times n plus 1 over 2, because the summation of k said n times n plus 1 over 2. So now what is our n in this case? Our n in this case is 200. N is 200. So we're going to replace all the n by 200. So 200 times 200 plus 1 is 201. And then 201. And then 200 times 2. 200 times 2 plus 1. 200 times 2 plus 1 will be 401. And then divide by 6. Plus 200 times 200 plus 1 will be 201. And then divide by 2. And then we would put that in the calculator to find the value. So 200 times 201 times 401. And then divide by 6 plus 200 times 201 divide by 2. Oops, divide by 2. Divide by 2. And we got 2706800. Okay, so this is the sum of these expression from k equal 1 to 200. And using the formula, we found that. Okay, so now let's try B. B, this is k. All right, so B, we want to find a summation from k equal 1 to 100 up to k plus 1. So similarly, we have the sum. So I'm gonna break it into two different summation. So 2k plus 1 for summation of 1. Okay, and from the first one, I have summation of 2, the coefficient times k. But remember, for the summation of coefficient, we can bring the coefficient to the front of the summation. So instead of writing 2k, we're going to find q times summation of k. So I bring the summation to the 2 to the front, the coefficient. And then 2 times what? Summation of k is n times n plus 1 over 2. And then summation of 1 is summation of a constant is constant n. So 1 times n. And then now our n is 100. So we're going to have 2 divided 2 is gone. So 100 times 101 plus 1 times 100, which is 100 times 101 plus 100 will be 10200. Okay, so this is the sum of this expression. If you want to verify, unless you have the TI-84, or you can use decimal as well. And then you put in x equal 1 to 100 of 2x plus 1. Oh, 2x plus 1. And you will have 10, 200. Okay, so that is how you do. And then you can try the other one. So for C, I want to find the summation of k equal 1 to n. I don't know what n is. N can be any number. K plus 2 to the power 2. Similar to number 1, we won't be able to apply the formula directly to this yet. Okay, so in order to do this, we will have to expand. So first of all, we will have always expand them into individual term. And we will have, remember the a plus b formula. So you have a squared plus 2ab plus b squared. So my a in this case is k, and then my b is 2. So we're going to have the summation of k equal 1 to n, k squared plus 2 times ab. So 2 times 2 times k, which is 4k plus 4. Okay, so now I have the summation of 3 individual terms. So I will break them down. K equal 1 to n k squared plus coefficient, bring it to the front. So we have k plus summation of 4. Okay, now we're going to apply the formula for individual summation. So you have summation of k squared is n times n plus 1. So this is going to be n times n plus 1 times 2n plus 1 over 6. This is for the first term. And then the second one will be plus 4 times n plus 1 over 2. And then the last one will be 4 times n. Okay, so that is the summation. So we want to simplify this, or you can leave it like that. Okay. And you can try the last one on your own and compare the answer in the last video. In the last of this video. And for the previous one, maybe you want to simplify 4 divide 2, but become 2 if you want to. So you're gonna have n times n plus 1 times 2n plus 1 over 6 plus 2n times n plus 1 plus 4. Okay, should be your final answer. And this is the answer for the previous problem.